Hey guys, recording my face a little bit here just so you see me. I am teaching. Alright, yes, I'm right here with you. Alright, Mr. Howell told me I should do it, so I'm doing it. Okay, so section 7.1, that's what we're going to do. Graph exponential growth functions. So let's kind of talk about chapter 7. Chapter 7 is actually it's not an easy chapter because it deals with something we call logarithms, but we're going to start off slow with dealing with exponential functions, which you guys should already know. So, exponential function, what is it? So here's some characteristics about exponential functions. Number one, the function is continuous and one-to-one. Continuous meaning if I drew it, it never leave, like if I was drawing it on paper, my hand, I would never have to pick up my pencil to draw it, right? There's not like two parts. It's continuous. I can just keep drawing. Never lift my pencil. One-to-one, meaning for every x value, there's only one y value attached to that x value. Next, the domain, which we've dealt with last chapter. I said, what is the domain of this? What is the x values of this? And in this case, it's the set of all real numbers. So if I draw you an exponential function here, okay, let's see, y equals something to the x power. So let's say 3 to the power of x. This is an exponential function because the exponent is x. Okay? So the domain here, it's like, what could x be up here? Could x be positive? 3 to the positive number, 3 squared? Yes. Could x be 0? 3 to the 0 power? Yes. Could x be negative? 3 to the negative 1 power? Yeah, that means 1/3. Right? So domain is always the set of all real numbers. So that's nice if I ever ask you for domain. Okay? Next, the x-axis is an asymptote of the graph. So, keyword, write that down. Asymptote. Basically, an asymptote is, a line that the graph will get closer and closer to, but never touch. Like this. Exponential functions, exponential growth, looks like this. See how that is curved, and it's going to go down, 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 almost touch the x-axis, but it'll never touch. It'll just keep getting closer and closer and closer to the x-axis, but never touch. That means that this line right here, this x-axis, is called the asymptote. A line that the graph will get closer and closer to, but never touch. Okay? So the x-axis is an asymptote of the graph, depending on the k value, which we'll get to in a second. The range, so one was domain, up here, all real numbers, easy, but the range will vary. Okay? The range in this case, what do you think the range is right here? What are all the y values? Well, they start basically right above 0, and they keep on going up. So the y in this case, it's all the y values are greater than 0. Start here, go up. Why didn't I put equal to? Because this thing will never touch the x-axis, so that's why I didn't put the equal to. So this is our range. Okay? And next point, the graph contains the point 0, a. I'm going to bring you to the equation here in a second, but you can write that down. 0, a. Alright? Because the actual general formula is, you should write this down, y equals a times b to the power of x. This is an exponential function in general. Okay? So this a is what this is talking about right here. Okay? So If I put in 0 for x, guess what happens? It's just a, right? Because anything to the 0 power is 1. So it's like canceling that out, and you're left over with a. There you go. And lastly, the graph y equals ab and y equals a times 1 over b reflect across the y-axis. You'll see what I mean by that. Okay, I'll draw you a picture here. Here's a little picture. Let's say this is 1, y equals ab, and then y equals a times 1 over b is this. See the reflection across the y-axis? That's like the mirror right there. Okay, there you go. Alright, so section 7.1 is mainly about exponential growth. Section 2, which we're going to do as well, is about exponential decay. So exponential growth, what it looks like in a graph, I kind of already showed you this, but I want to draw maybe a little better picture. Notice my function here. Okay, it starts off small, right? It's barely above the x-axis here, but it's increasingly bigger and bigger, and it just skyrockets, sky high, just gets real steep real quick, right? So this is an exponential growth. What do you know that grows exponentially? First thing I think of is bacteria, right? Notice a guy next to you sneezing in his hand. Oh, he didn't wipe it on his jeans. He didn't wash his hands. Guess what? Those germs are just growing exponentially. You don't see them, but they are. Okay? That's why you got sick yesterday. Okay? So, yeah, that's exponential growth. What else grows exponentially? Population, things like that. Alright, so definitions. Alright, so write this down. Y equals ab to the x power. If a is greater than 0 and b is greater than 1, which let's give an example right off to the side of this, like y equals greater than 0. So doesn't matter. Could be 1/2 times b. Let's give a base here of 3 to the power of x. 3 to the x power. Everybody understand? Here's my a. Here's my b to the x power. If you see this, this represents an exponential growth. Why? Well, just because a is greater than 0, b is greater than 1. There you go. Has to be a growth. It's going to look like this. Alright, it might be steep, might be little, whatever, but it's going up from left to right. Now, an exponential decay, alright, it starts with a lot of things. Population, death, I think, is an exponential decay. So it starts with a lot of things and it goes down exponentially. Okay? Notice the asymptote is still the x-axis here. So that's a exponential decay, which is actually section 2. What else here? So how do you know it's a decay? If a is greater than 0 and b is between 0 and 1. Let's just give an example. So if this had an equation to it, it could look like y equals greater than 0. Let's just say 3. We can say that. And b is between 0 and 1, which we could say, 1/2 to the x power. How do you know it's a decay? Because these things, this happened and this happened. So I mainly look at this guy and it tells me. Okay, so there it is. How do you know something's a growth? How do you know something's a decay? Just look at the equation. Here's an example of a growth. Here's an example of a decay. There you go. Here's a picture of a growth. Here's a picture of a decay. Alright, so graph y equals 2 to the power of x. Put that in your calculator, get some coordinates. Okay? What is a in this case? You don't see it, but there is one. Okay, even though you don't see it, it would just be 1, right? Y equals 1 times 2 to the power of x. There's my a, There's my b to the power of x. So b is 2, right? Y equals ab to the x. What is this, a growth or a decay? Well, a is greater than 0, check. B is greater than 1, so that means it's a growth. So basically it's going to look like this. We just have to find a couple coordinates because it says to graph. So type that in your calculator and just get a couple coordinates. Okay, get one here, get one here, get one here maybe. Alright, draw your curve. That's it. Doesn't ask you for anything else. I'm not going to spend a lot of time on that. You guys can type it in, get a few coordinates, draw your curve. You're going to be able to do that on the homework. Please just don't do this. Alright, oh, it's this. Or, you know, this. Don't sketch. I want a couple coordinates here. Okay? So basically just number 1, type it in your calculator. Number 2, get your table from your calculator. Here it is. Number 3, just start plotting some coordinates. You don't have to get this many, but get a few. Alright? And then draw your curve. Make sure you don't cross the x-axis. That's the asymptote. Okay? Draw your curve. Alright, see, draw, look at that last part. Draw left to right a smooth curve that begins just above the x-axis. Okay, there you go. You can practice those later. Alright, example 2, basically the same thing. It just says graph, so all you're going to do is put that in your calculator. 1/2 times 4 to the power of x. Get your table and make a smooth curve. So, number 1, plot. Okay. Why are they plotting 0, 1/2? Do you remember? Because 0, comma a is always on these exponential functions. So 0, comma a. So 0, comma 1/2, put it on there, and 1, comma 2. That'd be easy to do. Plug in 1 right here, and you'll get 2. So there's a couple coordinates, but you can just go to your calculator, type it in. And then just above the x-axis, so don't cross that asymptote. Pass through those points, moves up to the right. Make a smooth curve like this. Okay? That's how you want to graph an exponential growth. Letter B though. Look at letter B. What's different here? Negative out front. So that's going to change something. So you can type that in your calculator. Still graphing here. What happens when you have a negative? Well, you're going to get your table. And, well, what we could do is we already know 0, comma, a. What's a in this case? Negative 1. Okay, so negative 1 is a, 5/2 is b, and x is the power. There you go, 1, comma, negative 5/2. Now, what happens here, anytime you have a negative out front, like a is negative basically, it is a reflection across the x-axis. So, when you have here's your normal exponential growth, right? As soon as you have a negative right here, what it does is it flips it. And now it goes like this. Okay? That's what a negative does. So this thing I know is going to look something like that. Okay? So there it is. So get a couple coordinates from your calculator. Draw a nice curve. Just like they have here. Okay, that's it. Just get good at graphing. You can use your calculator to kind of guide you to get some coordinates. There we go. Here's the next type. Notice all this stuff. Write this thing down. Y equals a. Still got a, b to the x, but we got x minus h. Then we got our plus k. So the minus h is a part of the exponent, right? And then the plus k is not. It's just normal numbers out here. Okay. So look at the end product though. Number 1 we're going to graph, which you can use your calculator for. Okay. Now the normal, this is the normal y equals ab to the x. But when you have a minus h and a plus k here, what did that do to every other graph that we've worked with from day one? Translation. It's going to translate this thing up or down, left or right. Okay? So, the h always translates left and right. The k always translates up and down. Right? So, since this is minus 1, h is what? H equals a positive 1, and k equals a minus 3. So basically it's going to move 1 to the, since it's positive 1 to the right. So pretend this whole thing moved 1 to the right. It's not going to do much, is it? But everything's going to move down 3. So down 1, so 2, 3, whatever it is. You know, it's getting closer and closer to the x-axis, so 1, so 1, 2, actually right here, it's going to get closer and closer to what number? Negative 3. Actually, it's going to move a little right. So, okay. So, I mean, this is just a rough sketch. I'm just trying to teach you guys what to look for. It's going to move it right 1, left 3. So, what does that change within this? Change domain? Does it? Does it change range? Or does it change both? Because the normal functions, I told you what was the domain for a normal function as exponential function. All real numbers, right? So, let's look at this right here. Y equals 4 times 2 to the x minus 1 minus 3. Look at this. Here's how you want to find domain and range. Pay close attention. Domain, what could x be? Let's look right here. Could x be positive? Yes. Could x be 0? 2 to the negative 1? Yes. Could x be negative? Yeah, you could have 2 to the negative power up here. X could be anything, so domain does not change. Write this down. Domain is all real numbers. For any exponential function, that's always true. Always true. But what is the range? Just look at the picture, kind of like what I told you to do last time. Look at this picture right here. Where does it start? Look at all the y values. If I had to calculate all these coordinates, what are all the y values of these coordinates? What are they getting close to right here? All these y values right here are very close to negative 3, right? And what do they keep doing? They keep going up. Negative 3, negative 2, negative 1, 0, 1, 2. They're going up. So all my y values are what? Greater or less? Well, look at this thing. It's up. It's up here, right? It's above negative 3. So greater than negative 3. What if it was flipped below, which you're going to see soon? What if you had something like this? Let me just draw that picture. What do you think the range is here? Well, everything below the x-axis, so basically this particular thing would be y is less than, because it's all down here, less than how much? How much is this? 0. Should I put an equal sign here? No, because it never will cross negative 3. It never touches. It's an asymptote right here. The asymptote was this. Now it is this. Okay, so know how to find domain and range. It's not too bad, but it takes a few to get used to. Okay, there you go. Example 3 done.